A ball is dropped from a bridge 122.5 meter above a river. After the ball has been falling for 2 seconds, a second ball is thrown straight down after it. What must be initial velocity of the second ball so that both hit the water at the same time? And here is a bridge. On the bridge we are dropping two balls. One, when we drop, you see the words here. A ball is dropped, but the second ball is not dropped, it is thrown. What is the difference between drop and thrown? When we say it is dropped, then its initial velocity is 0. When it is thrown, its initial velocity is not 0. It has certain value, say u. Now, what we are supposed to find out? We are supposed to find out, we just search here, what must be initial velocity. That means we have to find out value of this u, initial velocity. Okay. Now, how do we solve the questions? The answer is, first, which are the quantities involved, we take care. Here the quantities involved are the height, the initial velocity, of course acceleration due to gravity, and the time. We know this is all belonging to kinematic equations. Now how do we get the equation? What is the second thing, or rather the most important thing is to get an equation which has got these quantities. So we have to search for an equation in the question, and for the equation, what is an equation? Equation is equal to. So equal to, we have to find the situations which have been given in the question. What are the quantities which are equal to? And for that equal to, you will find out, you will search for same. What is same here in the two situations? And we find it here, see here, same time. So this is our catching point to solve it. Always look for equation. What is the same thing for the given situation? So I write here same, equal. This is same. What is equal? Time for ball 1. Time for ball 1. But that is equal to what? Is the other? No. Answer is for the second ball. Second ball is dropped after 2 seconds. 2 seconds. So time for ball 1, time for ball 2 minus, no, ball 2 has taken less time, ball 1 has taken larger time. So if I want to put equal, then time for ball 1 is equal to time for ball 2 plus 2 seconds. If they have taken time t1 and t2, I will write here t1 for the first ball is equal to t2 for the second ball plus 2 seconds. This is the equation which we are going to work, and this will give us the solution. So whenever you find a question, a numerical for the physics, try to find out the equation, and the equation you will get whenever the same situation is given. Here time is same. This. So now you have got the clue. What we are supposed to calculate? We are supposed to find out initial velocity. So we must find out relation of initial velocity with time. With time, because we have the equation of time. So let's find out time in the terms of initial velocity. Okay. So for the first ball t1, how do we get the time in kinematic equations? V is equal to u plus at. Is it going to use? No, because here height is given. If height is given, then we have to use the ball is falling down and it falls down to earth here, ground, and it has taken time t1. It has a height of 122.5 meter. It has acceleration is equal to g. Okay, then these are the things given, and what is its u? Its u is equal to 0. Now for the second ball, What we know? U we don't know, we have to find it out. So we write it U. Then time T2. This we have already written. T2 is less by 2 seconds. So T1 minus 2, that is what we have written here. Okay, then when it is falling down, the height is same, 122.5, and they fall at the same time. So the total time is T1 minus 2, acceleration is same. So what is the time T1? What is the time T2? Do we have the equations with relation to S? So S and T, we have the relation number 2, and that gives us S is equal to ut plus half at square, and in this reference this will be equal to S is 122.5 is equal to, for the first case u is equal to 0. So S is equal to U into T plus half GT square, and value of A, let's put it G. When required we will put the value G, and this is T1 square. Okay, this is for the first ball, and this contains T1. So we can very well find the value of T1 from this. Now, okay, should we find it? Let's try. T1 square is equal to, this comes here, 122.5 multiplied by 2 upon G. This is value of T1 square. Let's keep it like this. Now we go to the second ball to get the equation of T2. Okay, how much is T2? T2. So in the second case again we put the same equation. 122.5 is S, U in this case is U, and T is equal to T2 plus half, this is equal to ut plus half G T2 square. Here it is. So now we put it, 122.5 is equal to, this is U into T2. So we must find the value of T2, and we know the value of T2. What is the value of T2? T2 is equal to T1 minus 2. Okay, so we solve it here. T2 is equal to T1 minus 2. We get the value of T1 from here. That means we must put the value of G over here. So this is 122.5 multiplied by 2 divided by 9.8, and the whole thing we make a square root, and then we get its value. So if you solve this, this comes to be 25, and T1 comes to be 5 seconds. If T1 is equal to 5 seconds, T1, root of this T1 is equal to 5 seconds, then how much is T2 is equal to T1 minus 2, that is 5 minus 2, 3 seconds. Okay. That value we put here. So U into 3 plus half, and this is 9.8 multiplied by 3 3s are 9. So here we get it, 3U is equal to 122.5 minus, and this will be 9.8 into 4.5. This comes out to be 78.4, and U is equal to, divided by 3, and it is equal to 26.13. So this is the initial velocity with which we must throw the second ball. And 26.1 we get here. Yes, this is the right answer, 26.1 meter per second. This is how question 1 is done. And now we go to question number 2. A ball is thrown vertically upward from the ground with a speed of 25.2 meter per second. How long does it take to reach its highest point, and how does it rise? So we have to find out how long does it take. That means we have to find out time. And what's happening? A ball is thrown vertically upward from the ground. Here is ground and it is thrown upward with certain initial velocity which is given to us 25.2 meter per second. When it is going up, acceleration acts down, that is equal to g 9.8 meter per second square. Okay, now what is being asked? Time. A is known to us, u is known to us, we have to find time. U is equal to 25.2, acceleration which is equal to g, that is equal to 9.8 meter per second square, and it acts downward. U is acting upward. So one quantity, two quantity, three quantities in reference, but three quantities do not make an equation. For equation we need a fourth quantity. The fourth quantity is not given here, but it is hiding somewhere which we are supposed to find out. How to find out that fourth quantity? It is hiding behind the words. Please see here that vertically upward to reach its highest point. Whenever a body reaches its highest point in vertical motion, we have one quantity given, and that quantity is v is equal to 0, because when it reaches here, it has to come back, and here what is its velocity? 0. So this is hiding here behind these words. So whenever an object is thrown up at the highest point, velocity has to be taken 0. So now we have u, v, a and t, these four, and we have the relation v is equal to u plus at. Put the values here. 0, a, acceleration is negative and its value is 9.8 into t. Therefore t is equal to, let's take it on this side, v is equal to u plus at. Okay, so t is equal to 25.2 divided by 9.8, and this gives us value of t. Okay, and this comes out to be 2.75. Time comes to be 2.75 second. Okay, we check here, 2.75 is here, 2.75 is here, so this answer should be correct. Now the second thing we have to find out is how high does it rise. That means we have to find this height h. For this h, again, what are the figures we have? We want to find out h, that is s, v, u, a. We have the third relation, and that is v square is equal to u square plus 2as, and here again we put the values. 0 is equal to, here it is u, 25.2, so 25.2 into 25.2, this is minus 2 into 9.8 into s, and here we take it on this side. S is equal to 25.2 into 25.2 divided by 2 into 9.8. 9.8, and when you solve it, do the necessary cancellations, and you will find it comes to be 32.4 meters. So time 2.75, and this is 32.4. So this is not correct, this is the correct option. So here we get option number C as the correct option. This is how it is solved. Now let's go to the next. A particle moves in an xy plane such that its x and y coordinates vary with time according to x is this much, y is equal to this much. So x and y are variable. That means its displacement is variable. X and y represent displacement. Remember, those are functions of time. Find acceleration. How can we find from the equation of displacement go to the equation of acceleration? Answer is in two steps. First, we differentiate x. What is given to us? X displacement and displacement in y direction. What we will find out? Acceleration in x direction, that is carrying the vector I, and acceleration in y direction, that will carry the j. Okay, so let's find out the magnitudes of acceleration. In x direction, the displacement x is equal to here t cube minus 32t. Then what will be the velocity in x direction? That is, we know dx by dt. With reference to t, it is to be differentiated. So we differentiate this with reference to t. So this becomes 3t square minus 32. Okay, this is velocity in x direction. But what we need is acceleration. And we know acceleration in x direction is equal to differentiation of velocity in x direction with respect to time. So this is d by dt of 3t square minus 32. Now when we differentiate it, then acceleration, if I write it a, acceleration in x direction is differentiation of this. This is 3 2s are 6t, and this differentiation as 0. So this is the differentiation of velocity, which is acceleration. But this is not a fixed quantity. It varies with the time. And for that they have given, if the time t is equal to 3 seconds, then what is acceleration? We put t is equal to 3. Then what is the acceleration in x direction? 3 6 are 18. In which direction? X direction. What is this? Magnitude. How we convert it into vector? Answer is, in x direction the unit vector is I. So 18I is acceleration in x direction. Right. Now the particle is moving in both the direction x as well as y. So we must find acceleration in y direction also. What that should be? The displacement in y direction is given to here 5t square plus 12. 5t square plus 12. So velocity in y direction is equal to 10t plus 0. This is velocity. And what is the acceleration in y direction? That is d by dt of velocity. So we differentiate it. When we differentiate it, it comes to be only 10. 10 into 1 plus 0. So this is 10. So acceleration in y direction is 10 because there is no t here. T is not there. Therefore, it is not a variable quantity. It does not change every second. It is a constant. Okay. So this is a constant. But in which direction? This is in the direction of y. So we can write it vector ay. In the vector form, it is 10 in the unit vector j multiplied with. So it gives the vector form. So the same particle has acceleration 18I in x direction and 10j in y direction. So here it is constant. Remember, for first second, for second second, for third second, every second its velocity, its acceleration do not change. Therefore, we take it 10 in the direction of y. So what is the net or the total acceleration? Net acceleration is equal to addition of the two, that is resultant. So we get the resultant in vector form. How do we get the resultant? Simply by addition. If you want to go for magnitude, then it is root of square plus square. But for vector form, we simply have to write it 18I plus 10J. This is acceleration, and we search for it, we find it is here in B. So this is our right answer for it. A vehicle is moving with a constant acceleration from A to B in a straight line AB, has velocity u and v at A and B. Here is AB, A, and here is B. Okay. C is the midpoint of AB. Here is C, which is midpoint of AB. Okay. If time taken from A to C is twice the time taken travel from C to B. If time from C to B is t, then from A to C, this time is 2t. And C is middle point, therefore, if this distance is equal to S, then this distance is also equal to S, the two distances. Vehicle moving with a constant acceleration, that means here acceleration is A from A to C, and from C to B also acceleration is A. Okay. Here the velocity is u and here the velocity is v. Now we have to find out the velocity of the vehicle at B. This v is equal to how many of u? So our question is v is equal to how many u? This we have to find out. The quantities A and the quantities which we have taken S and T does not figure here. Only this relation we know. Okay, let us start making it. How do we? We have to make the relation between V and U. Rest everything we can take help, but later it has to be eliminated. Okay, so we have relation from U to C. At C, when it reaches after the distance S, it must be having certain velocity. Let us say that velocity is V dash. Again, in time t it reaches V. So initial velocity u, final velocity v, the distance is 2s, the time is 3t in our language. Do we have certain equations? Yes. First, v u a s, that is third equation, and that gives us v square is equal to u square plus 2as, 2a, and here s and s, 2s. So this is v square is equal to u square plus 4as. Okay. Now if we go for t, then this v is equal to u plus a, acceleration a, and time 2t plus t, that is 3t, t into 3. So v is equal to u plus 3at. This is again relation between v and u, but we don't want this at, that has to be eliminated. Okay, this is our relation with as. Then if we go from A to C, here we get v dash. Okay, so with this v dash is equal to u plus a into time 2t, a into 2t, that is 2at. This is another equation we have. Okay, if we go from this place to this place, we have this equation, v is equal to u plus 3at. Now v dash is equal to u plus 3at. Here what is the same thing in this and in this portion? Answer is the same thing is s. Let us find s for this portion, first portion, and let's find s for the second portion, and these two s will be equal. So for the first portion, s is equal to first half S is equal to ut plus half at square. U into t plus half a t square, 2t square. Okay. This is S is equal to. So this comes out to be 2ut plus this is 4t square and 1 2 is cancelled, 2at square. This is the value of S which we have got from first. If we take this V and this is 2S and this is U, then V dash is not involved. How do we do that? That is 2S is equal to, 2S is equal to, yes, S is equal to ut, U into T. How much is the total T? 3T plus half a T square. This is total time is 3T and square of that is 9T square. So this we have 3ut plus 9 upon 2 at square. Now we have so many formulas here. This is 2S equal to ut 9 by 2 half at square. Okay. What we want, that S is to be eliminated, T has to be eliminated, or they must be converted into U or V. Okay. So let us start. Take this 2S is equal to as one equation and multiply this equation with this equation, or this is a simpler one. Let us choose this equation and multiply with 2, the whole equation, and put it here for elimination. So this 2 will make it 2S is equal to 2 2s are 4ut, 4ut plus this is 2 2s are 4at square. Now see, 2S is equal to this, 2S is equal to this, and if we do the subtraction, this is cancelled, and what we get here is minus minus, minus ut, and this is 4 and half, this is 4, so this is plus half at square, and this gives us what? Ut, put it on this side, so this comes to be ut is equal to half at square. Cancel t from both sides, so 2 multiply here, so this is 2u is equal to at. Yes, 1t is cancelled, this is at, 2 will come here, 2u is equal to at. We got the value of a into t and we need it here. You see, we had this relation here, V is equal to, from 1, V is equal to u plus 3 at, that is u plus at is equal to 2u, 3 into 2u. So this is 6u and 1u, this comes out to be 7u. So V is equal to 7u, and we check here, V is equal to 7u is option number C. So this is how we can make it. A car starts from rest, u is equal to 0. Accelerate it uniformly to, acceleration is uniformly to a speed of 18. V is equal to 18 kilometer per hour. Okay, in 10 seconds. This is kilometer per hour. Time given is 10 seconds. Okay. The distance covered by the car in this time interval is how much? S we are supposed to find out. So S, T, V, U. Okay. U, V, T, S. There is no relation as such because in every relation of kinematic equation, what we need is value of A. So value of A is not given. So we have to find out value of A with one part and use it in the second part. What we are supposed to find out? S. And for S, there are two relations. One is U square, that is V square minus U square upon 2A. And other is S is equal to UT plus half AT square, but you will find both need acceleration A, and that is what we don't have. So we have to find it A first. So the relation with A, what is the first equation? V is equal to U plus AT. We have the value of V, we have the value of U, and we have the value of T, so we can always find out A with help of it. Now let us do it, but all our answers are in meter, the time is in second, therefore it is working in SI system. So 18 km per hour is not according to SI system, we must convert it into meter per second. You know the feature 18, that is to be multiplied with 5 upon 18, this is the conversion factor. So this comes out to be 5 meter per second. This is velocity V. Okay, now we have to find out A. So V is equal to U plus AT. V is equal to 5. U is equal to 0 plus A, and T is equal to 10. So A is equal to 0.5 meter per second square. This is the A. Now with this we can find out S. Which one would we like to use? The final velocity is given to us, that is 5. Initial velocity 0. A is known to us, so we can find S with this equation. We can use second also, but in second again it is half AT square. Both are very easy, you can find with anyone. S is equal to V square, that is 5 square. 5 square minus 0 upon 2 into A is 0.5. So this is 5 5s are 25 upon 1, that is equal to 25 meters. So S is equal to 25 meter, and we have it here. S is equal to 25, option D. So now we go to the next question. The next question says, the velocity time graph for two bodies A and B are shown here. Then the acceleration of A and B are in what ratio? These are which graph? Velocity time. Here is velocity V, here is time T. So this is 25, this is 40. Now graph velocity, time, acceleration, how they are related to each other, that knowledge is on test. Acceleration is equal to dv by dt. V upon t. V upon t gives us tangent. dv by dt is tangent or slope. Slope or tangent of Vt graph. So the acceleration due to A, the velocity time two bodies A and B. So acceleration of A is given by tangent tan 25 degree. Okay, acceleration of B is equal to tangent of this angle, velocity divided by time. And how much is this angle? This is 40, so this is 50. Tangent 50 degree. Okay, so This is acceleration A, this is acceleration B. Acceleration of A and B are in the ratio. We have to find out this ratio. So acceleration of A divided by acceleration of B, these are in the ratio tangent 25 divided by tangent 50. This we have it here. Let us check the answer. Yeah, here it is. So we don't have to do anything like this. Tan 25 upon tan 50, tan 25 to tangent 50. It is given here. So our right option is option D. This is how we can make it. So what we have to understand, that acceleration is slope of the graph. Which graph? VT graph. And that is equal to tangent. The slope is given by tangent. So again I will write it. Acceleration is equal to slope in VT graph. And slope is given by tangent. And tangent is given by perpendicular upon base, but that is not required here. No perpendicular base are given. So this will be only tangent of theta. A man wants to reach point B on the opposite bank of the river flowing at a speed as shown in the figure. What minimum speed relative to water should the man have so that he can reach point B? If he wants to go from A to B, then this should be his relative velocity. No, his resultant velocity. You see, a man is being pulled by water in this direction. With what velocity? U. He has to acquire certain speed here. Let us say this speed is U of the man. This is U of the river. And this is resultant. Now depends upon this. It is depending whether he will go this path or he will go this path or he will go on this path. So how do we find this? This 45 is just in between. If I add it from here, this is 45, 90, 90. So it becomes a square like this. Only in the square this angle is 45. If it is a rectangle, then this angle will be either more or it will be less. So it has to be square. In the square, what is the property of the square? That these two sides are equal to each other. So if this side has magnitude, if this side has magnitude U, then what should be the magnitude of this? This is also U. Then only it is 45. Now the river has got velocity that is equal to U. Then what should be the velocity of the man? Here U man is equal to U river. 45 degree possible only in square. So U man is equal to U river. Therefore, what is velocity by man? It is U that is given. U. Okay. So this is velocity acquired by the, in which can reach the point. In which direction should he swim? He should swim in a direction normal to flow, in this direction. Then it is 45 degree and he should keep this velocity U. Okay. So man should have velocity U, direction normal to the flow. This is our answer for this question. And now let's go to the next question. This question says the acceleration versus time graph. Yes. The acceleration versus time graph of a particle moving along a straight line. The motion is basically in a straight line. Okay. Acceleration. There is certain acceleration of it. Draw the respective velocity time graph. Okay. AT graph is given to us. This is A and this is T. Acceleration, time, acceleration, meter per second square, time in terms of T. Okay. Now, this is 0, this is 2. It is moving in a straight line. So what is happening for the first two? We have to make a graph. Okay, I draw here. That graph should be velocity time. Velocity time. This has got time 2, 4, 6. I also make it 2, 4, 6 time. Okay, start with 0 here. Now, initially the acceleration is 2. Acceleration is 2 for 2 seconds. If there is an acceleration for 2 seconds, then there will be change in the velocity. So in 2 seconds, what will be the final velocity? This. So if we take final velocity as initial velocity as 0, acceleration is 2, 2, 2, 2. That means it is uniform acceleration. 2 for how much time? For 2 seconds. 2. So this is equal to 4. Okay, so velocity become 4 in 2 seconds. In 2 seconds, the velocity will become, mark it arbitrarily, 2 and 4. In 2 seconds, velocity will become here 4. This. In 2 seconds, velocity has become 4. So this was our first starting point. This is the second point at 2 seconds. Now, from 2 to 4, look here. 2 to 4, acceleration is 0. That means there is no acceleration. But if there is no acceleration, what happens to velocity? The velocity remain as it is. It does neither increase nor decrease. So from 2 to 4, velocity will remain as it is up to this. 4 seconds. After 4, for next 2 seconds, what happens? There is a acceleration. How much? 4. But this is negative. Means there is a retardation. So what happens to speed? Here the velocity is 4. Initial velocity is 4. For this calculation I am doing 4 to 6 calculation. What was this calculation? This was 0 to 2 second calculation. Okay, 4 to 6 second. The initial velocity is 4. Acceleration is equal to, I take it from here, that is minus 4. Then what will be the time? 4 to 6, 2 second. What will be the final velocity? We want to find out. So V is equal to U plus AT. U is equal to plus 4, A is equal to minus 4, T is equal to 2. So this is 4 minus 8, that is equal to minus 4. So here again we draw minus 2 and minus 4 and minus 6. So at 4 the velocity is 4. But at 6 the velocity become minus 4. So I draw here minus 4 at this point. This is minus 4 at 6. Okay, at 4 it. So I got the point 1, 2, 3 and 4. Let's join it and this will be like this. This. So this graph, this line and this line. This gives the correct VT graph, which is for the same vehicle which has got this AT graph. So this AT graph is for a vehicle, its VT graph will be this much. And this we have done part by part. 3 parts are there, 1, 2, 3. When acceleration was there, it has increased. No acceleration, its velocity remains same. Retardation. And this calculation we have made according to this. So this is how we make this question. And now we go to the next question. An open elevator is ascending with 0 acceleration. The speed velocity v is equal to 10 meter per second. A ball is thrown vertically up by a boy when he is at a height h is equal to 10 meter from the ground. Okay. There is an elevator here. I say this is stand of the elevator and from the ground at a height of 10 meter. This elevator is here and this elevator is moving up. The elevator velocity is given as 10 meter. This has velocity equal to 10, but acceleration is how much? 0 acceleration. Acceleration is equal to 0. Now, once we know acceleration is equal to 0, velocity is equal to 10, let's go with the story. He is at a height of 10 meter. The velocity of the projection is v is equal to 30 meter per second. He is throwing a ball up and the velocity of this ball is 30 meter. U is equal to 30 meter per second, but it is related to what? Related to elevator or related to ground. So 30 meter per second with respect to elevator. With respect to elevator, the elevator is already moving up with certain velocity. Okay. Now find the maximum height attained by the ball. How far the ball will go here? Maximum height is achieved by anything thrown up when its final velocity becomes 0. Ball final velocity at the height. This goes here and here its velocity becomes 0. And after that it turn back and come down this way. Okay, so here velocity is 0. Here velocity is 30, but this lift is moving up. Now here we have to consider whether we should add this 30 with this velocity 10, whether we should make the subtraction of the two. What should we do? Addition, subtraction, or nothing? So please examine. The acceleration is 0. The 0 acceleration makes it a frame which is inertial frame. What is inertial frame? Inertial frame is just like a train compartment in which we are moving with uniform velocities. When there is no acceleration of a system, no acceleration of a body, then inside the body all the things are having similar velocities, so that is known as inertial frame, and in that all the Newton's laws are applicable, all equations of kinematic are applicable. So here first we declare, because the acceleration is equal to 0, therefore this is an inertial frame. If it is an inertial frame, all our formula will be applicable as it is. What are those formulas? What we have to find? Maximum height attained by the ball. We have to find S, that is height of the ball. What is given to us? Initial velocity 30. Do we combine it with 10? Answer is no, because we are taking this platform as inertial frame. It has to go from here and attain certain height with respect to this. Okay. So u is equal to 30 because there is no additional acceleration. How much is net acceleration? That is only because of the earth, g, and that we take as round figure minus 10. Okay. Then to get the maximum height, what is the quantity hiding when it is given to us that it has gone to maximum height? Answer, v is equal to 0. v is equal to 0. Now with this u, a, v, s, we have a relation s is equal to v square minus u square upon 2a, and here it will be 0 minus 900 divided by 2 into minus 10. Minus minus cancel, 20, and this comes to be 45 meter. So the distance traveled from this location to this location is 45 meter. This is moving. Finally, when it reaches to the maximum height, the distance between the two is 45 meter. From the earth, it will be more because the whole system has moved like this. The whole system has moved. So what is happening? Here is the ball, and this ball is going up. The system is also going up like this. So what is this 45? This might have reached somewhere here, and this is the 45 here, from here. It is only for your understanding. That you will say, why don't we calculate this? My answer is, why should we calculate it? Because they are asking maximum height attained by the ball. They have not written with reference to ground. So what we are trying to find out with reference to elevator. This is what we have found out, 45 meter. Okay. So this was our part A. If they have asked with reference to ground, then we will have some other calculation with this. Then we will not take 30 because 30 initial velocity is taken what? With reference to elevator. So when we get the answer S, that is height, that is also with reference to elevator. So if we take it with reference to ground, then our height will be with reference to ground. Now we go to second part, the time taken by the ball to meet the elevator again. From here it starts from the floor and it comes back to the floor. Floor to floor. Floor to floor distance is 0. Again, if you are confused that floor to floor distance, how it is 0? Because the floor is moving up. So our answer is, we are not considering that. We are considering it just like a train compartment. Inside the compartment, this is a inertial frame. So everything we have to do as if we are not seeing outside, because the acceleration is 0. So this is inertial frame. So inside we have thrown the ball up. After some time the ball comes back to our place. So we have to find out time. So floor to floor distance is 0. Time taken we have to find out. So we take it as t. Acceleration. Acceleration due to gravity is working there. There is no any other acceleration. Other acceleration is 0. So only acceleration throughout this is equal to g. That is given to us. And This is distance, this is t, this is a, and initial velocity. Again, with reference to floor. Everything is with reference to floor. Floor to floor, 0. With reference to floor, velocity 30. With reference to floor, acceleration minus 10. Yes, it is minus 10 because there is no additional acceleration. And t we have to find out. Now, u is there, s is there, t is there, a is there. We have the relation s is equal to ut plus half at square. Here s is 0, u is equal to 30t, and here it is minus half, a we place as minus 10 into t square. Take t out, bring it here, that will be eliminated. Or you can say it is 30 minus 5t, and 1t is taken out. This t is brought here, so this becomes 0. So this is 30 minus 5t is equal to 0. That gives us 5t is equal to 30. So t is equal to 6 seconds. This time is equal to 6 seconds. So this is our answer, the time taken by the ball to meet the elevator again. So this is B part of it. This was A part of it. Now we come to part C. Time taken by the ball to reach the ground after crossing the elevator. Now ground comes into picture. With reference to ground, initial velocity of the ball is equal to u30 with respect to platform, elevator, and the elevator itself is having velocity 10. So what is the total velocity with respect to ground? U ball with respect to ground is equal to 30 plus 10 is equal to 40 meter per second with reference to ground. Okay. Now to reach the ground, from here this is the initial position and it goes up, comes down to the ground here. So this is final position. How much is the displacement initial to final? That is equal to 10 meter, but this displacement is in downward direction, so I write it minus 10. Okay. So S is equal to minus 10, U is equal to 40, acceleration is equal to G is equal to minus 10, and we are supposed to find out time taken, T. S, T, U and G. A. What is the equation? S is equal to ut plus half at square. Let's put the values here, and when we are putting values, it comes to be S is equal to minus 10 is equal to 40t minus half 10t square. Okay, so let us divide everything with 5, and this equation simplified to 5s. So this become equal to, bring it here, 5t square minus 40t minus 10 is equal to 0. And this leads to, divided with 5, this leads to t square minus 8t minus 2 is equal to 0. And now you can find two roots of t with the relation. The root t is equal to b plus minus root of b square, that is 8 square, minus 4ac, 4 into 1 into 2, that is 8, and minus into minus become plus. So this become 8 plus minus root 72, and that root 72 is 8.5, and this becomes 16.5 with the plus, and there will be a negative value. The time is not negative, so we reject the negative value and we take up only positive value, which is 16.5 divided by 2, that is 8.25 seconds. So when the ball goes up and comes down to the ground, the time taken is 8.25 seconds. Remember how much time it has taken when it came back to the platform, 6 seconds. But when it comes back to the ground, when it goes here and comes here, wherever the platform is going, we are not concerned. It has left the platform with velocity with respect to ground, 30 plus 10. 40 was the velocity of the ball, 40. What was the distance? 10. 10 is the distance. What was the acceleration? Minus 10. This we have taken, and initial velocity we have taken with respect to ground, 40. So in this way we solve this for the timing for coming to ground. So this is how we have solved all these three. And now we go to a particle is moving with a velocity of v, which is a variable velocity with respect to time. It is a function of time. 3 plus 60 plus 90 square centimeter per second. Find out, number 1, the acceleration of the particle at t is equal to 3 seconds. Number 2, the displacement of the particle interval 5 seconds to 8 seconds. Okay. Now, this is variable expression. And what we are supposed to find out? Acceleration. So the first thing, if you want to find out definite value of acceleration, we must have formula of acceleration, relation of acceleration, the function of acceleration. How do we get it? From velocity to acceleration, we know acceleration is derivative of velocity with respect to time, dv by dt. So the same thing, d by dt, find the value of v, that is 3 plus 60 plus 90 square, and this is equal to, differentiate, d by dt of 3 is 0, d by dt of 60 is 6, and this is 9 2s are 18 t. So this acceleration has the expression 6 plus 18 t. This is from velocity to acceleration by a single differentiation. Okay. Now, question. Acceleration of the particle at t is equal to 3 seconds. We should put the value of t at 3 seconds. So, acceleration at 3 seconds is equal to 6 plus 18 into 3. This is 18 3s are 54 plus 6, that is 60. Meter? No, not meter, it is centimeter. Centimeter per second square. Okay. This is acceleration at 3 seconds. Then displacement of the particle between the interval 5 seconds to 8 seconds. Now we have to find out displacement. So we must have the relation of displacement. Now what is the relation of displacement? Okay, the relation of displacement is, let's find it out, initial velocity this is what we have done, question A. Now we are doing B. Initial velocity at t is equal to 0. What was velocity here? T is equal to 0, 0. So velocity is 3. Let's call it u is equal to 3. Okay. Then what is acceleration? Acceleration is variable. So we cannot apply formula of kinematics, which are formula 1, 2, 3, because all were there for uniform acceleration. So those formulas are not possible. Then what should we do? We should go for expression of displacement. How do we convert expression of velocity to expression of displacement? The answer is v velocity into dv if we integrate it. Sorry, v into dt. If we integrate it, what we get is displacement x. You know, x is equal to velocity into time. So if there is a variable velocity, we will write it variable as a function of t. So that is integration of v dt. This formula is all well known to us. So here we have x is equal to this whole thing multiplied by dt. So this is 3 dt plus 6t dt plus 9t square dt and constant. Okay, so this is equal to integration. 3 dt integration is 3t plus 6t dt 6 t square upon 2 plus 9 t cube upon 3. This. Okay, so this comes to be 2 3s are 6, 3 3s are 9. So this is, I will write it straight, 3t cube plus 3t square plus 3t is equal to x and plus constant. A particle is moving with a velocity of t is equal to 5, t is equal to 8. Two values. We don't know the value of constant. Let it be there. So x at 8 seconds is equal to here 3 into 8 into 8 into 8. That is 8 8s are 64 and 8 4s are 32, 5 1 12. This is 3t square plus 3 into t square 8. 8 8s are 64, 64 into 3 plus 3t plus c. This is x at 3 8 seconds. And what is x at 5 seconds? Let us put it as 5. Okay, so, or you can simplify this thing. First, this will come out to be, no, let's write it first. X at 5 seconds, so this is 3 into 5 5s are 25, 5s are 125 plus 3 into 5 5s are 25 plus 3 into 5 plus c. Okay. So displacement of the particle in the interval, this. That means we have to subtract the 2. Then we will find the displacement during this interval. Subtract. After subtraction, all this will become minus. Okay. Now we simply have to do some calculations. So this comes out to be this line, this total is 1752 plus c, and this thing is this 3 take common, 125 plus 25, 150 and 5, 155 multiplied by 3, that is 465 plus c. Subtract. When we subtract, c gets cancelled out, and what we get here is 1, yes, it is 7, 1287. And the unit is centimeter. So the distance from 5 seconds to 8 seconds is 1287 centimeter. This is part B, and this is how we do it. Thank you.